the topic for today is how to deploy cloud-native.NET apps with container apps. Yeah, so before we get started, so my quick introduction about myself. So my name is Swaminathan Vetri. You can call me Swami. I work as a cloud solution architect at Maersk. So I've been focusing mostly on cloud native technologies, Kubernetes, Azure, DevOps, and .NET. I used to be .NET developer. Now I'm also learning Java and then working on Spring Boot based microservices. And also kind of have my hands dirty on Terraform and things like that. So yeah, cloud and cloud native is my area of expertise, which I'm working on currently. I'm also a Microsoft MVP and a developer technologies since 2016. And that's my Twitter handle at the rate SV Swaminathan. If you want to follow me on Twitter and GitHub, you can feel free to do that. I also started a YouTube channel in 2020 when the pandemic hit, and that's my YouTube handle. And I used to write blogs, that's my blog handle. And apart from these tech stuff and the work, I also do some bit of photography, traveling. I'm also like an self-learned, self-taught dancer. And yeah, I play table tennis and interested in home automation. So I'll be interested to talk to any of you on any of these topics as well, apart from the tech stuffs too, right? All right, so today's agenda is pretty straightforward and sleek. So we'll just start understanding what and why of container apps, and we'll also understand some of the concepts of container apps. And of course, there are already a lot of containerization options available on Azure, right? I also mentioned a few of them in the poll today. So let's also understand what are the differences between each of them, and then which one can be used for which scenarios, etc. And then we'll get into the demo of how to deploy and scale a .NET Cloud Native application, right? And I'm looking at the poll and the questions. If you have any questions, please feel free to raise your hands, and then maybe we could pause and then we could take it on the course of it, right? So I want to be more interactive as much as possible. So yeah, so be ready for more questions, be ready with your questions, and be ready to be answering the questions as well. Okay, cool. So what are container apps? This is just a definition from Microsoft documentation, right? Azure Container Apps enables you to run microservices and containerized applications on a serverless platform. That bakes in a lot of jargons here, right? It's microservices, containerization, and then serverless, right? We've all been looking at some of these differently. So now this is one particular offering that's going to bring everything together, and you'll be able to run your microservices application. You can containerize them, and then it's completely on serverless. You don't have to worry about in which containerization runtime it is working on, etc. Right? So where do I use? I mean, let's debrief all of these in the course of it. So, but before that, where can I use this? What are the use cases where I can use container apps? So it could be just an public API endpoint. If you want to expose, you can use that. If you want to create an API, REST API, you can create that API and then deploy it into container apps. And then if you want to have any background processing running, if you want to basically create a worker .NET worker service that wants to listen to an Kafka topic or an Azure service bus, and if you want to do any kind of processing, you can very well do that as well. And any kind of event-driven processing, like I said, I mean, background processing and event-driven processing are kind of related, but not exactly the same, right? So query your application or anything that you want to do, depending on as and when any message arrives, you can deploy those kind of workloads also in container apps. And of course, microservices, where if you have multiple services are built together to accomplish a single application, this one, you can use that as well. Can deploy different microservices into container apps, and then you can build your entire solution with container apps. So yeah, there is also bottom, there different scaling criteria are present, which we will talk about it in the demo part, right? So now, let's understand some of the basic concepts of container apps, right? So the top level logical grouping is called an environment. So as it's called out here, it's the secure boundary around a group of container apps, right? As you can see in the picture here, environment is a logical boundary which will have one environment could have multiple container apps, right? And this environment is what is deployed into an VNet as a virtual network. So one environment means all the container apps within that particular environment will be deployed into a same VNet. And then all the applications within that particular environment share the same log analytics workspace. So log analytics is what is the main observability platform which is being used by the container apps. So if you want to have all of your logs together, then you need to deploy all the container apps into the environment, right? So yeah, so when to use environments, first thing is if you want to manage related services, or if you want to deploy different applications to the same virtual network, or if you want to instrument Dapper applications that communicate via the Dapper Service Invocation API. How many of you heard about Dapper? Can have a quick show of hands, I mean virtual hands. I can just take a look at it here. Have you guys heard about Dapper? Distributed Application Runtime. Okay. Feel free to raise your hands. It's okay. Okay, I don't see anyone. Okay, maybe yeah. Okay, good. I see one person has worked on Dapper. Yeah, we'll also talk about Dapper in little more depth over the course of it, right? So it's basically it's more for cloud native application where you can use this Dapper, which will run as a sidecar, and then it helps you to basically address your cross-cutting concerns like your authentication, your service invocation, service discovery, etc. So all those are actually, if you want to use any of those for related services, then all of these services need to be in a single environment. More on Dapper in the later time. Thank you, Advait. And yeah, again, if you want to have the application to share the same Dapper configuration, you can use these kind of environments. And again, if you want the application to share the log analytics workspace, you can use environments for that, right? So if you don't have any of these things, then that means you can create different environments for your different applications. For example, if you're creating a standalone API, REST API with using a .NET Web API, right? You can deploy that into one, and you can create one environment, and inside that you can create multiple container apps, and then you can deploy them. Right, like that. If you want, if you're building two different APIs and if they both are not really related, then you can definitely create two different environments and then you can deploy them separately. Excuse me. And yeah, so within an environment is where we have a container app, as you can see in this picture here. Environment is the top level thing. Inside we have a container app, and then we have these containers here, right? So containers are grouped under the pods. So it can be either Linux, x86 or x64 images, and you can deploy the containers from public or private container registries, and they share a hard disk and the network resources under the hood, because of course they are all deployed into the same environment. They share these hard disk and the network resources. Right, so containers is the actual containers what is running your application, be it a .NET Web API or a .NET Worker process or your microservices. Everything is under a container. Moving on, so there's also something called revisions. Is another concept which we need to understand when we work with the container apps. If revisions are nothing, they are nothing but the immutable snapshot of a container app version. Let's say first time I'm deploying a .NET Web API into the container app, right? That is when the first revision will get created. And after that, anytime, let's say if I've set up a CI/CD pipeline for my .NET based applications, and then every time I make a commit to my main branch, the pipeline will run and it gets deployed into the container app, right? So on every new deployment is going to create a new version, new revision. That's why it's called an immutable snapshot, right? And you can have multiple revisions running at the same time. And I'll also explain where you will use revisions in the next slide. And there's a limitation as of now where you can maintain up to 100 revisions in a container app, right? I'll also take a look at the chat window on the side. So if in case you guys are having any questions, please feel free to post that, and then we can take that up too. Right. So yeah, revision use cases here. So every time you want to release a new version of your application, you can use a revision for that. Or if you want to do a rollback, let's say I have my version 1 and then I try to do my version 1.1, and after I release it, I found a bug in 1.1. And if you want to quickly roll back to my previous version, I can use a revision for that, right? Or if you want to do some advanced deployment strategies like A/B testing, where for some users you will show your version A of your application, and for some you will show your version B of application. Try to gather the feedback, right? So in such cases, you can use revisions, or also blue-green deployments. This is also another deployment strategies, right? People working on web app, I see quite a few have responded. You've been working on web apps, right? Where you have something called deployment slots, where one particular slot would be like a production, one could be like a staging, and then whenever you want to release a new version, you go and push it into staging slot, and then you kind of swap it, right? That's a sort of a blue-green deployment. If you want to do a similar thing with container apps, you can create two different revisions, and then you can change one revision to the another, right? And next thing is also another deployment strategy, which is called canary deployment, where if you want to start slow, like 20% of the traffic, which is shown here on the right hand side in the picture here, I want to send my 20% of traffic to my version 2, and my 80% should be on version 1. And once I get the feedback of 20%, and once I find that it is working properly, then I can slowly increase the 20 to 30, and then 50, and then I can slowly bring it down, right? That's a canary deployment, what we can do. So if you want to do those kind of things, then revisions are the ones which you need to use in the container apps. And now just talk about application lifecycle. So deployment, like I said, first time a new deployment is happening, that's when a first revision will get created. And then whenever there's an update that is happening, let's say a container image version 1 is updating to image version 2, and that's when a revision 2 will get created. So at that time, you can have two different revisions in an active state. And once you make the revision 2 as a primary one, then the revision 1 will become inactive, and this becomes a primarily active version, right? That's how you can imagine how your containers or the application lifecycle is in the container apps. Excuse me, I have a bad throat. So So this is just to put things together. Let's see if you're having microservices. So you could create one container app per microservice. That's what, as you can see, container app one for microservice one, and that can have multiple revisions. It could be revision 1, 2, up to 100 revisions it can have, and each revision will have its own replicas, and each replica will have its own containers, right? So some of these terminologies, if you have already been working with Kubernetes, you could relate what is a replica and what is a revision and things like that. But people who are not really familiar with Kubernetes, you don't have to really worry about any of those different ways. How do you achieve those replicas or revisions in Kubernetes? Instead, everything is available like out of the box for us in the container apps. That's one of the good things going with container apps, right? Yeah, we also have a detailed comparison on which use cases we are going to use it, which we'll talk about in a while. I believe so far you're following me and you're able to understand what is what in the container apps. So now that we understood different concepts, how are we going to basically monitor our applications, right? There are multiple ways we can do it. We have also log streaming, like with any other Azure app service or Azure functions. You can also do a log streaming. Basically, whatever the logs that are getting emitted into the console of your container, you can just get that streamed into your local machine when it's a local machine using ACCLI commands or either in the portal as well. Or you can also navigate to container console if you want to connect into the container, and then you can figure out what's happening. So for example, you've deployed a microservice where one container app is having service A and the container app B is having service B, right? And you would want to connect from service A to service B as part of your application, right? And you figure out that whenever you're getting a request to service A, it's failing with the reason that it's not able to talk to service B, right? To quickly troubleshoot it, what we could do is we can just go to your container console of service A in the container app A, and then just do a curl or whatever, just ping and see if you're able to at least establish communication between container app A and B. Right? So in those kind of quick troubleshooting, you can directly log into container console also, and then you can do that. Right, and of course, all the metrics which are emitted by the container app is all would be fed into Azure Monitor metrics. And like I said, the logs all are going to log analytics, which is where we can go and query how the container apps are performing or working. And of course, since the metrics are already there, you can also leverage Azure Monitor alerts to basically set up alerts for your application execution. Let's say if you want to see if the replica counts are going high or if the CPU requests are going high, if you want to set up certain alerts on certain criteria, we could leverage Azure Monitor alerts for that. Right, and just to categorize, so the log stream and container console is something you would use for your dev and test environments. Of course, you'll not be streaming your production logs into your local machines or anywhere, right? And container console also, we are not going to allow anyone to log into our production containers. So for dev and test, we can use that, and for your higher environments and deployments, we'll be able to use these tools, right? Excuse me. And what are the other features, right? So it's health probes. I'm not sure how many of you have heard of the concept of health probes, right? This is also again something that's coming from Kubernetes ecosystem, right? Kubernetes has the concept of these probes. That means, let's say I am creating a .NET Web API, which is going to talk to a SQL server in the backend, and it's going to do CRUD operations in it, right? So now the moment I deploy my application into it, as long as my application is able to connect to a SQL server and then establish a connection, there is no point in sending any request to my application container, right? Anyways, even if you send a request, it's going to fail telling connectivity is not established or whatever be the reasons, right? So that's where the health concepts like health pros will come into picture. You can deploy it and you can check for liveness and readiness. That means whether your application is first, your container has come up or not is what is your liveness will say, and then your readiness is nothing but is it ready to take any incoming requests. Yeah, right. So all those are also you can configure using container apps as well. And Dapper integration, like I said, Dapper is a distributed application runtime. In the microservice example, right? Let's say I'm having a microservice A, I'm owner of it, and then there's somebody else is getting service B, and then we want to talk to each other via maybe an Kafka topic or any other service bus, etc. Right? So I don't have to actually provide my service bus configurations in the service A or in service B. You could use Dapper as a layer to basically offload that. You'll set up all these infrastructure related things, the configurations in Dapper, so that it makes it more portable. Tomorrow, if you want to move your application to another orchestration, for example, you started with container apps, and then tomorrow, if you want to move it into Azure Kubernetes service, right? You don't have to change anything on your application side. The Dapper configuration is what you just need to change. Or for that matter, today you started with excuse me. today you started with Azure Service Bus, and tomorrow if you want to change it into Kafka, right, all these kind of external dependencies and other things, we can leave it to Dapper configuration, and then you can offload that part. Basically, Dapper injects a sidecar to your application container, and then the connectivity will happen via the Dapper, right? I mean, Dapper by itself is a big topic to talk about it. I'm just trying to give at a high level what it means. And now, if you want to do Dapper integration in your containerize on your microservices application, you can very well do that with a click, with a click of a button. So that's also possible in the container apps, right? And KEDA based auto scaling. How many of you heard of this term called KEDA? Big show of hands. Hmm? Okay, so KEDA is nothing but Kubernetes event-driven autoscaler, right? So that's another Kubernetes autoscaling concept, right? So typically, autoscaling, I'm sure some of you have heard, right? At least in the world of Azure web app itself, we have some of these autoscaling, right? You can set up the CPU limits or memory limits, and then depending on that, it is going to really scale up the applications, right? Assuming if we are doing an event-driven processing, that means I am an owner of a service that's going to produce an event into an Azure service bus, for example, and somebody else is creating another consumer service that's going to consume the events, right? So now for the consumer service, if you want to scale that service, the scaling factor would be to, let's say, if there are 1,000 events in my service bus topic, in the service bus queue, right? I want to maybe process them in a faster fashion, right? So at that time, you might need to increase your number of instances of the consumer, right? But then if the number is going from 1,000, if it's going down to 10, right, for example, then you don't really need to have multiple instances of a consumer running. So basically, depending on the spike in your load, you might want to increase the number of instances, or you might want to decrease the number of instances, right? That's what we call it as scale up and scaling down, right? So for us to do that, obviously, since it's more of an event-driven processing, you can't definitely go with an CPU or a memory-based limits, right? Because obviously, since your worker process is not doing much work, the CPU's memory will never spike, right? But what we need to ensure is, as and when more events or messages are published into my service bus or Kafka topics, is when I want to scale my consumers, right? In such cases is when you can use something called KEDA, Kubernetes Event-Driven Autoscaler. So you can also use that, leverage that KEDA in container apps as well, right? Again, this is more of an scaling rule you can set up. So if you need to do that in Kubernetes, you might need to create multiple YAMLs, and then you have to deploy your KEDA custom resource definitions and few other things you need to take care. So all of those are abstracted for us, and then indirectly with a click of a button and a few configurations in the Azure portal, you can definitely leverage KEDA as well here, right? And and then the other features are like manage identities. I'm sure people working on Azure would have heard about manage identities, right? So with manage identities, it makes it a lot easier to authorize one application which is running in one Azure service with another Azure service, right? For example, if I'm having a .NET app, again, the same example with the .NET Web API talking to Azure SQL DB, right? So Azure, it's .NET Web App is deployed into Azure Container App, and my Azure SQL is also on Azure, right? So I don't really need to create a connection string to connect to this. If I can authorize my Azure Container App as an authorized identity on my Azure SQL side, I can directly connect to it, right? So I'm just taking one example, Azure SQL. There are a lot of other services like Azure Storage or other things as well where managed identities can be used. So if you're using container apps as a deployment target, you can very well leverage managed identities as well there. Yeah. And custom domains, for example, if you're deploying your front-end applications into Azure Container Apps, you can very well map custom domains into the container apps as well. It's not that by default you will get an randomly assigned domain name, fully qualified domain name, which I'll show in the demo. But if you want to change it and map it into a custom domain, you can very well do that too. Somebody is, you have any question? Okay. No worries. And yeah, so for high availability and disaster recovery, we also have zone redundancy here. Since it's more of a serverless platform, that means you don't have control on what VMs or which and from where it is provisioned, etc. Right? Everything is taken care of by Azure for us. We just need to mention to run my container how much of a CPU and how much of memory is needed, and that's about it. Rest all is taken care by Azure for us, right? So they internally manage the HA, high availability and disaster recovery by leveraging zone redundancy for Azure Container Apps. And of course, if you want to run these container apps in Azure Arc enabled AKS clusters, that's also possible. If you have an use case where you want to have everything controlled within AKS, you can very well also do that too. right? And yeah, so just as a quick recap, why should I use it? So we can run multiple container revisions and manage the container application lifecycle, which we just saw about how an application gets deployed and how revisions are created and then how they get activated and inactivated, etc. Right? Basically, it gives an ability to run multiple versions of your containers. Right, and then you can also auto scale your apps based on KDA supported scale trigger. And the good part is this application can scale down to zero, which wasn't possible with any other things like your Azure Container Instance or web app for containers, etc. Right? Scale to zero is nothing but, let's say, in the same example of my service bus topic, the service bus queues, right? So if there are no messages in service bus, it doesn't really make sense to run your worker process all the time, right? To save cost, you can scale it down to zero, and whenever a first event comes into picture, at that time you can bring it up and then start keep it running. And as long as there are events in flow in pipeline to be processed, your container app will be running, and then the containers will go down to zero. And yeah, of course, you can also enable HTTPS ingress. Since it's on the cloud, definitely we would want to enable any communication by HTTPS ingresses, right? That's coming out of the box for with container apps, right? If you are leveraging Azure Kubernetes service, anything else, you might need to create a separate Azure load balancer, and then you have to provision them separately. So you don't have to do any of those. The moment you create a container app, again, another checkbox, if you just tick it, it will automatically give you an HTTPS based ingress. And yeah, split traffic, like I mentioned, across multiple versions you can do with blue-green deployments. And yeah, if you don't want to enable, if you don't want to create a public facing endpoints, if you want to make it more internal endpoints, like I said, container app A wants to talk to container app B internally because they're on the same virtual network, and I don't want to expose my container app B to anyone else. I want my container app A to be like the front end or the front facing app that needs a public endpoint, and the other ones they don't want it, right? If you can also do that in container apps using internal ingresses, which are also taken out of the box. And again, you can build microservices with Dapper. And yeah, you can run containers from any registry. It's not restricted to only ACR. You can also, excuse me, include Docker Hub and any public or private registries you can connect to it, and then you can deploy your containers from there. Yeah, and how to manage these things, right? You can use Azure CLI extensions or Azure Portal or ARM templates or biceps or there to create and provision your Azure Container Apps, and then any of your modifying your rules and things like that, you can very well use ARM templates or AZCL extensions. Portal is good for your lower environments. So you can just go over and click, and then you can create your infrastructure. And then after that, you might want to set up your CI/CD pipelines, for which you can use GitHub Actions to create pipelines to deploy into your container apps, or for the any other infrastructure updates. Let's say I've created an ingress now, which I don't want to enable it, etc. Right? Any kind of infrastructure changes if you want to do, you can use bicep or ARM templates to do that. And yeah, we can also, like I mentioned, every environment is going to be associated with a virtual network. There are two options. Either we can provide our own virtual network. Let's say if you already have an existing virtual network where other applications are deployed, like you have Azure SQL DB or your Azure web app or anything else like that, right? If you want to push these container apps also into the same VNet, that's also possible. Or we can leverage we can create its own standalone virtual network as well. And of course, you also have a built-in secret store where you can manage your secrets. You can just add your application secrets in it, and then those secrets will be available for your application running within the container app. And of course, you also have the option to connect to Azure Key Vault, because the since managed identity is also available, you can leverage that as well. But if you don't want to take that route for a simpler simplicity, if you want to maintain your secrets in Azure Container App purview, you can very well do that too. And of course, you're monitoring the logs using Azure Log Analytics. So these are some of the high-level pointers on why we can go with the container apps, right? And yes, it has generous quota, which are overridable to increase limits on a per account basis. These quotas this is something which keeps on changing, right? So I kind of put a snapshot of what when I took it, whatever the quotas, I'll just share about it. But yes, it's more generous to start with. But then there's an actual question there. Don't we have enough container offerings in Azure already? So then how are we going to make a decision on when I should go with container apps versus what kind of containerization service I need to use, right? That's why I tried to put together a table here to talk about some of these popular containerization options in Azure. So the first two columns is in Azure App Service, and then Azure Container Instance, Container Apps, and the Kubernetes Service, right? So if you go one by one here, the application composition, for example, what kind of applications can be run? Right, in the app service we can run application, or it can be a standalone application, right? Like an .NET application, you can directly publish your .NET DLLs into your Azure App Service, or you can also run containers here, right? And all the other three are primarily for the containerized models, right? And whether this is PaaS or serverless offering, oops, sorry. So Azure App Service is a PaaS, and container instance and container apps are serverless. Oops, what's happening? And this is again another PaaS service. And state management, whether we want to we can use a stateless, whether this particular offering manages, provides an ability to have a statefulness in it. It's not like running a stateful application. It could be both. But yeah, this Azure App Service is primarily stateless, and container instance is also stateless. That means it doesn't really maintain any state of your application running inside it, right? And in the container apps or Kubernetes, you can run stateful workloads as well. For example, if you want to deploy a database as a container, right? You can very well do that with AKS, but you cannot do that with your container instance or app service, right? Because it's a stateless thing. And web hosting, does it provide any web hosting? For Azure App Service, yes, there's a built-in web hosting for it. And it doesn't matter where you are really doing your web hosting part, because this is primarily working on your containerized model, right? Your web hosting, as in the web application, can be hosted anywhere, but any other backend components, you can put it into your container instance or container apps or in Kubernetes service for that matter, right? And from the developer experience perspective, local debugging. So if you want to work with any workloads that are to be deployed on Azure App Service, you can use IIS Express, Orchestral, etc. And for container instance, you'll use a local container runtime. That means you can use Docker desktop or Rancher desktop or any other containerization tools on your local machine, and then get that built. And as long as you're able to create an image which is on the container runtime CRE compliant image, right? Then you can very well deploy that into any of these things. And for Kubernetes, you will use Minikube or Docker or other kind and different other Kubernetes local tools are available, which we can use. And from the application update perspective, yeah, we use something called deployment slots here, where you have a staging slot and then production slot. And for the container instance, there is nothing called an application update, because it's a single instance which is running. Whenever you want to push a new version, it will bring down a container instance, and then it comes up with a new instance. It brings up a new instance with your new version of your image. So there's nothing like an application update. But in container apps, you will use something called revision management, which we just talked about, right? And then the Kubernetes, well, you will use something called rolling update. So yeah, we'll talk about rolling update. But if you want to say, let's say I'm running 5 instances of my application, and I can very well mention how many instances should be always available. For example, 2 should be always available. That means it will first create a new instance for 3 containers, and then once those 3 are available, is when it will start tearing down the next 2 containers, and then it will start bringing another 2 containers. That's what is called a rolling update in Kubernetes. And auto scaling for Azure App Service, we have built-in service for it. And container instance, there's nothing. And Azure Container Apps, you define something called scaling rules. And here in Kubernetes, you can also do cluster auto scaling or at a pod auto scaling as well, using HPA, which is nothing but horizontal pod autoscaler, or using CADA. Right, and some more things. This is like the limits, scale limits. So with app service, 30 instances and 100 with app service environment. And container instances, you can run 60 container groups per subscription. And this is the restrictions as of now we have for Azure Container Apps. 15 environments per region per subscription, and then you can have 30 replicas per container app. This is at a container app. So if you remember the hierarchy, environment will have multiple container apps, and each container app will have multiple revisions, and each revision will have multiple replicas. All right. That's how the hierarchy is. And here Kubernetes is more of 5,000 nodes is what you can go. This is again on a star I've put. I think I missed to mention that condition here. It depends on a on a specific. We have to work with Microsoft and then get that particular thing ready for us, scaled up for us. And load balancers, this has an integrated load balancer. If you know in the app service, the moment you deploy an application, it creates with an whatever your application dot azure websites.net, right? So it's integrated there. Container instance doesn't have it, and container apps also has a built-in load balancer. It also comes up with an fully qualified domain name. And for Azure Kubernetes service, we need to use either load balancer or an application gateway. And multi-region failover, for example, if you are creating an application that is going to be used across multiple customers by sitting across the globe. For example, I could have my customer sitting in APAC region, or in Americas region, or in Europe region, etc. Right? Then you need to ensure whenever a request coming from an European customer, the request has to go to your European data centers, and so that the latency and other things will be reduced, right? So for those kind of things, you can use existing tools like Traffic Manager or Friendor, which is applicable across all the things. None of these has their own built-in multi-region related things, right? And this is an important thing, suitable architecture. So for example, if you're having a web application or an queue-based application or a worker kind of a model, you can use Azure App Service. And if for a container instance, you can run microservices. Microservices as in individual services can be deployed into individual container instances. And if you want to run any standalone batch jobs or task automations, you can use those, because as soon as your task is complete, that container will go down, the container instance will go down, right? So you can definitely save a lot on your cost. And container apps is for microservices, full-blown microservices, and event-driven architecture. And the same is applicable with Azure Kubernetes Service as well, right? And all of these what I've shown is all taken as a reference from the Microsoft Learn documentation. Also show the documentation in as part of the demo. So the links are already captured here. I'll share this deck with Kasam, and then that will be published to everyone, and you can take a look at it from there, right? All right. So enough of talking. Let's get into the demo. Before that, are there any questions from anyone?
Yeah, I have a question. This is Advait. Uh,
Sure.
you have almost covered for everything for the container app and its
Mm-hmm.
the other options provided
Mm-hmm.
by Microsoft for containerization.
Mm-hmm.
So, but yeah, what I have not seen is probably the Microsoft Edge one, where the existing pass or the
Mm-hmm.
other apps which Microsoft provides, which
Mm-hmm.
which can be deployed over the Edge systems.
Mm-hmm.
So yeah, Microsoft Arc
Mm-hmm.
or the Arc services, which you have not covered up. And I have the
Yeah.
question related
Uh-huh.
to the Azure App Service,
Okay.
which can be which has certain features which are also there in the Arc based
Mm-hmm.
services, like these the logic apps,
Mm-hmm.
standard logic app, right? So
Mm-hmm.
how so basically my you even went through differentiating the decision making things,
Mm-hmm.
where in what each service has, so
Mm-hmm.
based on your business requirement what you can refer to. But
Mm-hmm.
the question is like, if I have certain requirements, which
Mm-hmm.
since our business is dynamic,
Mm-hmm.
how we can the once we leverage the features of the one service, and
Mm-hmm.
supposedly that service now is not providing the next requirement of business, how we
Mm-hmm.
can leverage or push that whatever we have achieved so far in the particular service to the next service, whatever whichever service is providing that
Mm-hmm.
feature, how we can push our existing solutions, develop in one service and then move it to the next service.
Okay. So here you mean the service is an Azure service, if I'm not wrong, right?
Yeah, maybe like
Mm,
let's talk about the container app. So container
mm,
app has certain features, and
mm,
then what I realize is no, now I have to move to the Kubernetes service,
mm,
or I have to go for the Arc-based services. So
mm-hmm.
how can I move our services from the container app to the
Okay.
Kubernetes services or the Arc-based services?
Okay, sure. So before I answer that, right? So this is one good article from Microsoft itself, right? How to choose a particular content service. See, because choosing a service is a conscious decision we'll have to make. Right? That's point number one. With the limited understanding of whatever the requirements we have, we will definitely be able to evaluate what would really work for us, right? And that is point one. Point two is, let's say since we're working in a containerized model here, right? Your application specific logic and everything is anyways baked into your application image, right? And what we are dealing with here in Azure is more around the flexibility it is offering on different these different services. For example, what we can leverage out of Azure App Service versus container instance versus these kind of things, right? So for example, container apps is more for a Kubernetes style workloads itself, right? Where it will helpful is for an I think I'm sure some of you would understand that to Kubernetes is not a simple thing to anyways learn and then operate as well, right? You need this dedicated team to manage those clusters. Though we say we are going to use AKS, which is another managed offering, once the cluster is available, you still need to take care of a lot of your the certificate handling, your gatekeeper policies, and few other things are there, right? So it is basically an it's not just only our application team. We also need to look at from the maintenance and platform perspective how we are do we have that do we have the teams or do we have the teams and skill sets to really manage those, and then only we can do the transition from one service to another service, right? So what I'm telling, it's not purely your business requirement alone, it also comes up with the maintenance aspects of it, and then your infrastructure management. Do we have the sufficient teams to really manage these and provision these different infrastructures, right? A lot of other things we need to factor in when we move from one service to another service. right? Having said that, from the application perspective, if you look at it, like I said, since we are looking at a containerized model, we can definitely deploy these containers into AKS as well, which is anyways a full-blown service orchestration service which you can leverage, right? To start with, you can start with your the container apps, and then you can definitely use the same container images and then push it there, right? That's how I would say you can transition. And again, we also look at some of these features like the managed identity. What are some things that are very specific to this, and whether that is going to be available in the other service or not is also another evaluation we will need to do, right? If we already know that, yeah, in the future maybe I might want to transition to a different service, then it would be better to design and have and make a choice which is kind of little agnostic to say, right? So that it'll help you in the portability in the long run. Yeah, instead of tying so deep into each of the individual services, try to keep certain things as generic, which is across. For example, leveraging maybe something like in log analytics something which is common across all the different services, right? So you can start pushing that into it. Like application insights could be available with only a couple of them, maybe Azure functions and Azure app services you might have. But if app insights is not really tying up with your Kubernetes, I'm just giving an example, it is definitely there. So
Okay.
if you choose anything like that, is when we might need to reevaluate the choices, right?
Yeah,
Does
yeah,
that does
yeah.
that does that help?
Yeah, I was a bit aware about only the
Okay.
concern is, yeah, only the concern because what you're referring in the documentation,
Mm,
this is also a nice document. There is another documentation which talks
mm.
about the cloud native, and there
Yeah,
is a PDF, right? Yeah.
correct.
So
Yeah,
in both the documentation, the details are given by Microsoft in a
yeah,
nice way.
yeah.
But yeah, when it's really a time of implementation, what the certain things really hampers the performance, or
Mm,
the architecting decisions is
mm,
basically take an example AKS, and its
mm.
versions are always getting upgraded
Correct.
in 3
Yeah,
or 6 months, and yeah, then
correct.
we really found ourselves in the much difficulties.
Yeah, that's what,
So
like as mentioned, AKS also, though the clusters are provisioned, as you rightly called out, version management, upgrades, and everything is an
yeah,
ongoing
nicely done.
activity. We
Yeah.
need to have dedicated teams. That is where if we don't have such separate platform team, so to speak, right, then it's better to use some of these PaaS or the serverless offerings so that everything is taken care by Microsoft internally, right?
Yeah.
Excuse me.
Uh, but yeah, certain things are directly available from the Microsoft images. To
Mhm.
leverage on that, there is yeah, we have to go with this
Yeah.
containerization. Yeah.
Correct. Yeah. I mean, it's a tough choice. There's no one size fits all for sure, right? And it is more context specific as well, right?
Yeah.
Because certain things we feel maybe the app service is a good choice, and then we can go and deploy it there. And then, like you said, after some time, maybe if you want to have an integration between this and another application, if there seems to be a bit of an disconnect there, then obviously you might need to transition from here to another one, right?
Yeah, yeah.
That's
As
that's
well
why.
as then if on-premise applications, then yeah, it's better to maintain it at a edge and then connect internally. So
Mm,
then also we have to decide on the containerization in that case. Yeah,
yeah.
true.
So, and yeah, just to touch upon that Azure Arc, but I'm not actually much familiar with it. That's why I didn't really put that related content in here. But yes, you can definitely also use some of those AKs on Azure Arc as well. Yeah, but I have not explored much, so I didn't really put that in the comparison.
Oh,
Yeah,
okay. Yeah,
yeah,
there is no much documentation even if you search for, but Azure Arc
yeah,
app is there, which is
yeah.
they have more elaborated on that. But if you
Correct.
search specifically for the logic apps or the functions or some other services, then yeah,
Mm,
limited documentation probably
yeah,
they are coming up with. Yeah.
yeah, yeah. Right. Okay. All right. Any other questions? Okay, if there's nothing, then we could get started with the container apps. So this is, I mean, I have created some of container apps already. So I'll just quickly show the experience of how a new creation of container apps would be, right? So I'll just say create. It comes with an default quick starter. Basically, just choose the resource group, and then just let me just say CA Dear-azure live demo. Excuse me. And this is a recently launched product, so it's not available in all the regions yet. As you can see, mostly in the US, it is there, but nothing in on India data centers yet. So you need to also carefully make a choice whether that region availability is important for you or not, right? So just choose a region, and then container apps environment is what will get created. So here is where we can create a new environment, or we can use an existing environment, right? So here, let's say if I want to say, DINV, Dear-azure. So zone redundancy is where I can choose the HA part, and monitoring, yeah, whether I want to create a new log analytics workspace or I can use an existing one. And I'll say networking, do I want to use our own virtual network or an existing one, right? Sorry, the new one or an existing one. I don't have anything here, so it just doesn't show anything. But yeah, so I'll just, in the interest of time, I'll cancel that. And next thing, if you go to app settings, is where you can choose either you can use a quick start image, right? Then you can have this simple hello world container will be created for us. And here is where these are the default values that are given. If you want to do a custom deployment of any of the existing images available either in ACR or in Docker Hub or other registries, we can also do that. So this is like the name, and I can choose a registry here, right? Maybe if I choose this registry, I might have other images already available. Yeah, there is a web API I've just created, so I can just use that and choose the image what I want to deploy, and then we can choose the memory limits here. So this is the kind of memory and CPU limits as of now. The maximum you can go up to is 2 CPU cores and 4 gig memory. If you're looking for, if you are having more CPU intensive workload which you want to deploy in the containerized model, then you can't use container apps for that. Then you might need to go with Kubernetes, where you can provision any number, any amount of CPU and memory as per your nodes limits, right? So you can choose this, and here is what I mentioned as the ingress part, right? So ingress, when you say enable, it will automatically create an external ingress. And again, you have the option to choose what from where you want to accept the traffics. Is it limited to container apps environment alone? That means only any container apps within that particular environment will be able to talk to it. Or do we want to make it accept traffic from anywhere? Right, and what kind of transport we want to use, HTTP 1 or 2. If you're building a gRPC based microservice in HTTP 2 is what you would enable, right? Or are we are okay to allow the insecure connections, and what is the target port in which application is running? We just specify all of those and then just create, and then you get your new container up and running, right? This is about quickly getting started. So I've already created a couple of them, so I'll just quickly show that, and we can go into the other bigger application. So I believe this should be the default one. So this is something I created for a different meetup earlier. So the moment you create the quick start project, right, you will get something like this. Welcome to Azure Container Apps is what this is the quick start image what is being run. Basically, if I create that, you will get that. And this is the ingress, public ingress, right? We have enabled the public ingress, so it automatically comes up with this random name. So this is your container app name what we have given, and with this which is suffixed with some random name for us here, right? And the region and Azure Container Apps.io, right? This is what you will get, and as you can see, this is the managed container app environment and the log analytics workspace from where we can go and monitor things, right? So I also have another basic deployment of the web service, web API basically. See, I kind of what I've deployed here is a basic. If you do a .NET new web API with which is .NET 7 based web API, which is what I have done, and then I've deployed it here. I've pushed that as an image into my container registry, and from the container registry, like what I showed in the previous screen, right? I have just used that and then deployed it here. Oops, there. Yeah, so basically this is in public endpoint, the weather simple weather forecast API, what we get out of the box, right? That's exactly what I've used, and then I've deployed it here, right? So some things what I wanted to quickly walk through is on the other settings, what we have here within the container apps, and how do you manage these different revisions and scales and other things, right? So I think we just talked about the ingress enabled part. So if you don't want to do that ingress, I can go ahead and go to ingress, and then I can turn it off, right? So if I just say it's not enabled, then it just I'll not be able to access any of those, right? And I can also put IP restrictions. Though I say I want to accept traffic from anywhere, if I know from where I want, let's say I want to back this particular ingress with an Azure API management, for example, right? Then I can do that, and then I can allow only specific traffic coming from specific services or from the specific IP addresses. Okay, which are the restrictions which I can add here. Since it's a demo one, I have not added any of those. So ingress is where you will go ahead and do these. And authentication, it also comes with built-in IDP providers. You can choose any of them, and then you can set up authentication for your application. So we can choose from any of these, either Microsoft, Apple, Facebook, GitHub, etc., etc. And we can set up those. And then the secrets is the secret store, which I'll show in a bigger app, which we have it. I think I also have it here. Basically, the ACR secret is what is maintained here. And you can also set up continuous deployment directly from the container apps, right? I have set up one of my repository Azure Container App Pug demo to this particular container app. So that's why it is showing up here. And it also, it's two-way basically. You create your GitHub workflow separately, when I say separately, in the repository directly. And in that repository, in that particular workflow, you can connect to this container app instance, container app basically. Then it'll show here. Or when you are starting with a new one also, you can go ahead and set it up. So what I mean is, if I go to this, here doesn't have any continuous deployment. It is not there here. You can go ahead and choose a repository here. This is another way to set up your CI/CD pipeline. If you do from here, what it does is automatically this is going to create an GitHub workflow file. I'll also show how that file will look like. You'll get a GitHub workflow file, and then that gets converted into your Git, so that any further deployments will happen automatically via CI/CD as and when you push any changes to your GitHub repository. Right, so it's two ways basically. Either you start from the Azure, you start creating this particular container app and then go from here, or like a typical if you're more mature DevOps kind of a model, you can directly create your repository in GitHub and then create your GitHub workflows separately, and then that also will link to this particular container app. And yeah, custom domain mapping is where you will do here. I don't have any mapping yet. And Dapper settings is, like I said, this is how you will enable it, which is app and the port, and then what are the other things you want to add. So here you can say what are the different components you can add here, right? If you want to do is a service discovery or whatever the different components, I can just use those, and then I can set it up for the Dapper part. And yeah, this is where you create your manage identities under the identity section. Yeah, and let's move on to this revision management, which is more interesting and the new thing in the container apps. So here is where we can see how many revisions are present, and there are multiple modes. Single means there can be only one active revision, or you can change it to multiple mode. So it says multiple revisions. That means I can, when I enable multiple revisions, is when I'll be able to do those blue green deployments or canary and things like that, right? Because as you can see, currently there's only one instance, and that traffic is taking us 100%, right? The moment I enable this multi-revision, then I will start seeing the previous versions as well, and then I can go and set up the different rules on how on what is the traffic percentage I want to, traffic split, what I want to do, etc. Is it done? Is it done? Okay, it's going on. Yeah, okay, there's a question. Yes, Sadhvai.
The question is, can we have just like a deployment slot? Can we
Mm-hmm.
have two different deployments for a
Mm.
revision, for multiple
Mm.
revisions? So
Two different
supposing,
deployments, two versions of deployments, right? Two versions of the same
yeah.
image.
So supposingly, I have one solution already,
Mm-hmm.
and that is we have created by default it create one revision. Now
Correct.
I want to upgrade it, okay,
Yes,
and
yes.
I have to give it to, let's say, 20% of
Mm.
my users
Mm.
to consume
Mm.
the that
Yes.
updated one,
Mm.
and
Mm.
then if they mention that it's all okay, the solution
Mm.
is all good working, then I
Yeah.
can give it to 100%. So
Yes,
how
that's
can we
exactly.
deploy the next upgraded to the
Yeah.
with the name of the next revision?
Yeah, so basically what happens is, as you can see here, CA Web API Pug Demo is the app name which I've created. And this is like your revision, one of the revision instance here. Okay. As you can see, there are two instances here, right? What to typically happen is, first thing is you need to enable this multiple mode, right? Which you can do via your CLI, or you can come and do here. And then next deployment, when it happens, it will always get every time a new deployment of an image is happening, it creates a new revision, right? And as part of that, we can set these rules. Now I'm showing from the portal, but the same thing you can do via your AGCLI commands or via your the bicep commands, right? So here you can come, if in case you have not set it up via the bicep or anything to start with, you deploy the second version, and then you can come here and then say, let's say you want to do 50% for this, and then another 50% for this, right? And then you just need to save it. Then what would happen is automatically Azure Container Apps will start splitting the traffic between these two revisions here. And then slowly you can change that, and after a while, if you want to make it into 80-10, sorry, 80-20 or 90-10, and then you can make it 100 and 0.
Yeah.
That's
Okay.
exactly what is the purpose of these revisions here.
Yeah. 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 And then how to archive the old solution or remove the old solution?
So basically there is like I said, the 100 revisions is what is the maximum limit, and then it gets like an deleted automatically, right?
Okay.
I also haven't seen any specific page to delete a revision, right?
Mhm.
I was looking for that. It's more like an rolling kind of a thing you can think of, right? You keep creating it,
Okay.
and then after the 101, if you create the first one, will get automatically deleted.
Okay.
Yeah,
Okay. Okay. Thanks. Thanks for his explanation. Yeah.
yeah,
It's it's
no
uh,
worries.
it's just like a deployment slot for me. Yeah,
Yes, yeah.
understood. Yeah,
It is,
okay.
but it works a little differently. There, it is you will get a separate what is it, like a staging URL, etc. But here
Yeah,
it is directly you are doing like a more of an traffic splitting you are doing with the same ingress. That's
same.
a subtle difference here. Yeah.
Yeah, yeah, yeah. Sure. Thank you.
And yeah, if you want to look at the containers and the properties, what we have set up for the containers, that is what is here. You can choose the revision name, and then it shows what is the container name and what kind of things are running here. And scale and replicas is where we'll set up the scaling rules. Maybe this part I will show up with a different application, a little bigger application, so that you can appreciate how these things are working together, right? But yeah, the place to go for scaling replicas is where you can define your scaling rules, where you can set up multiple rules. So I've created like an HTTP scaling rule for this particular application. So we'll show this demo in a while, right? And there are also other rules which are available, which I'll talk with a different application. Okay. So yeah, so that's at a high level, and yeah, log stream is where you can go ahead and look at the log stream. So as you can see, this revision scale to 0. That's why it doesn't really show anything. Maybe if I choose another revision, it might show up. Yeah, this is how you can connect. It's similar to what you do in Azure App Service or functions for that matter, right? This is my STD out of my container basically. It just shows that, and you can also log into to the console of the container from here. And yeah, so all of these you can directly do from the portal within the container app area itself. So this is where now I am in my container actual image, where I can see my what are the DLLs that are deployed as part of this image, right? So with that basics built, I would like you guys to take a look at another application. How many of you have seen this .NET podcasts? You guys heard about this app called .NET Podcasts? Anyone? No? Okay. Let me open this and then show to you guys. Have you guys seen .NET Conf, the event that happened in November? Okay, so this is basically a reference application which is built by Microsoft. This is like a podcast application, right? It's a working podcast application. Let's say if I do a sign in here, it's just a dummy sign in, but yeah, you can listen to multiple different .NET podcasts, right? So you can click on the subscribe, and then it just shows there this like a Hanselman's podcast, and you can just look at the episodes, and you can listen to it, etc. Right. So this particular app is completely open source, and the code is what is present in Microsoft's .NET Podcasts, which I kind of forked it, and then I've deployed it into my own Azure subscription for the demo purpose, right? So I just showed the app what it is doing here, and the infrastructure and the app architecture is something like this, right? So this is basically another tip. Anyone who want to understand how different .NET technologies like your Mavi or your hybrid app or your Wasm and other things are coming up together, you can definitely take a look at this one. As you can see, the front end is built with Mavi for different with different platforms, and we have an web application which is based on Blazor Wasm, and it also has multiple other Azure services. And what we are interested today is this part here, right? Second, yeah. So this area where we have the container apps, right? This is where a portion of the microservices, the APIs and the ingestion and other things are part of your container apps here, right? It is a pretty bigger application, but what we're going to focus is the container apps, and we're going to look at how scaling in the container apps is achieved in this application, right? Yeah, so going back for that, I'm gonna bring up a couple of commands here. So basically what I'm trying to do is there is this podcast ingestion container app, right? And there are three apps basically. One is an ingestion container app, another is the actual API container app. As you can see here, it says replicas is 0. That means it's scaled down to 0 now, right? And this is the podcast API CA, as you can see here. This has an one app, one version, one replica which is running. Excuse me. What we're going to do now is we're going to generate some load, and then we are going to see how the auto scaling is going to work now. Just a second. I'm sorry, I'm still recovering from bad throat and cold. So this is the URL. Okay, maybe I can quickly show that as well. Okay, go back to my podcast RG. Podcast API CA is this. This is the ingress what we have got, and we're trying to basically hit the endpoints here, right? So if I go open the Swagger spec for this, these are different API endpoints available. We are going to basically push a feed, create a new feed, and what that post endpoint does is it's going to publish a message into service bus topic or a queue, basically a storage queue, and from that queue there's another worker process that is going to read that, and then it is going to push into the database, right? That's the operation that's happening here, which is what is also shown here. These are three API app is what we are going to hit, and ingestion app is what is the another one, which is a worker process, and these two are connected via this feed queue. As you can see, this feed queue. So we will now hit this API, and that's going to publish messages into the feed queue, and from there it will be consumed by the ingestion, and it will be pushed into the actual database. Okay. So yeah, let's simulate that. We might see some intermittent errors. It's okay. So yeah, it is trying to push that. And as and when we keep doing this more, basically, I'm just trying to simulate the load. It happens, you should start seeing these replica counts increasing. As you can see, it became 1 now, right? I'm just running this for every 5 seconds. So it was 0. That means it was scaled down to 0. And the moment we started seeing certain load, basically, I can let me see if I can open that storage account. Use feed queue. It's already processed, is it? Okay, let me do some more things and see. Okay, so now if we push certain things, as and when we get messages here, the replicas count it will start processing, basically, right? So that this is basically an queue-based scaler what is set up here as part of this app, and this is basically an concurrent request-based scaler. So maybe let's do one more experimentation by pushing by generating load for our get API, right? Instead of post, maybe we'll just do for get here. So I'm going to use a tool called Hey to just hit maybe 1,000 requests with a concurrency of 10 and to this get endpoint, right? If I keep doing this for some more time, you should see that this replica count will keep on increasing. So basically what I'm trying to showcase is as and when the load increases, depending on the scaling rules, what we have set up, automatically your replica count will keep on increasing, right? Just to showcase how that is happening real time is where I'm having these two different container apps, and then I'm just showing how dynamically the scaling is happening. Okay, 77 responses. As you can see, now it became 3 replicas, right? There's actually a rate limiter also, which is implemented in this API. I think that's why we are getting these 503s. So ignore that for a while. As you can see, the replicas has become 3 now because of the load what we've generated. It's able to automatically do that, right? Now, so how is that set up? We can quickly take a look at that too. So if you go to podcast API CA, this is my API one. And if you go to scale and replicas, so you have this HTTP scaling rule, which has concurrent requests are 20. The moment it gets 20 requests, it will start scaling more. The scaling minimum is 1 and maximum is 5, which is what is happening here, right? The same thing if you go to the podcast ingestion container app, here if you go to scaling rules, it says queue scaling rule, right? So here based on Azure queue, and the queue name is feed queue, whenever the queue is having 20 messages in it, then it is going to start scaling up, right? That's why it's here, as you can see, 0 to 5, right? So when there are no messages in the queue, it doesn't make sense to run this worker service, so we've just mentioned 0 to queue. So if you want, you can, if you think you want to edit this and change it, you can very well do that. You can just edit this and then deploy it. But what I've set up is more of a CI/CD for this, with all the workflows and everything is also part of this repository. So I'm not going to go into details of that, but yeah, so you can go ahead and modify anything in this application, and it gets deployed automatically to the container apps, right? So yeah, I think I just have 1 more minute. Maybe I'll just take a pause and then see if there are any questions. Are you guys able to understand what I've been showing, like how how setting up the scaling and other things are much easier with the container apps?
Yeah, true. I have one question. This Advait again.
Mm-hmm. Yeah.
The last application which you were showing,
Mm-hmm.
where you are raising the HTTP request. So
Mm-hmm.
what that application was?
Which one? This
Yeah,
one.
this one. Yes.
That's Hey. That's a small load testing tool, basically. Load generation tool, sorry, not load testing tool. Load
Okay.
generation tool. I'm not sure if you've heard of something called Apache Bench. There used to be a tool called Apache Bench, so it's kind of a replacement for
Okay.
that. So you can use this. So it gives nice summary. So the total 24 seconds it took, and then what the slow as fast is, and response times and other things. Yeah. So just to generate loads, you can use that.
Okay.
Yeah. And this is a script which is part of the repository itself. It's part of the code what is created by Microsoft, right? In this .NET podcast repo itself has those the simulation part. So if you go to the docs, demos, you have these Azure Container Apps, and you can see the partial script. Basically, it's again doing a partial call only. It's working a post method. So for simplicity, for get, I use that. Hey, typically it's the same. Basically, we're trying to generate load to see how the pods are coming up and going down. Yeah. So I also share this particular repository link, which is pretty good. Like I said, it gives a good details of all the different .NET components and how they are working together, right? And it is easy to set this up on your local machine or on Azure as well. Documentation is pretty neat, which is what I followed, and I could get this up and running in my Azure here, right? As you can see, this all this are coming up. Yeah, so that's pretty much what I had. I think we started with the understanding of container apps, and we also understood how it's comparing with the other containerization tools, and we saw a high-level quick demo on some of the features of container apps, especially on deploying and then scaling them dynamically. Yeah, and yeah, open for questions.